Hi and a very good morning to all of you. Today we'll be doing a chapter called Speed, Distance and Time. Right. So first of all, we would start with a basic formula. You all must be knowing that distance is equal to speed into time. Right. From this formula you can make out all the other formulas. For example, time is equal to distance upon speed and speed is equal to distance upon time. Clear? These are the three mother formulas and we will be learning their applications in this chapter. Now, second of all, the one very important thing is our units, right? What are the units of speed, distance and time? So first of all, talking about the distance. We will be calculating our distance in terms of kilometers or meters, right? We will be only using centimeters in the case of questions of trains and relative speed, right? Our time would be measured in seconds or hours with an occasional mention of minutes, and our speed will be a combination of both these units, right? That is kilometers per hour or meters per second. However, we will not define our speed in terms of centimeters per minute ever, right? Now, another important thing is the conversion, right? 1 kilometer is equal to 1 kilometer per hour, is equal to how many meters per second? For this, we need to learn one thing, that to change kilometers into meters, we know that we multiply 1 by 1000. Right? Per means divide. 1 hour has how many seconds? It has 3600 seconds. Right? So we will bring it into lowest terms. 2 5s are 2 18s. So here we got our answer, that 1 kilometer per hour is equal to 5 by 18 meters per second. Clear? Now, for example, I am given that a speed of 72 kilometers per hour needs to be converted into meters per second. So what I would do, I would simply multiply it by 5 upon 18. 18 ones are 18 fours are 4 fives are how much? 20. Right? To convert this speed in meters per hour back into kilometers per hour, I would simply multiply it by the reciprocal, that is 1 meters per second is equal to 18 by 5 kilometers per hour, right? These are our two very important conversions. Fine. Now, you all might be familiar with one more thing from these formulas you can very well relate, that speed and time. Can you find some relation between them? Yes, I hope you find it out. That these are inversely proportional to each other, right? Now, for example, I drive on a speed of 50 kilometers per hour to say Delhi. Delhi is 250 kilometers from here. So by that formula, right, or any one of these, I get my time to reach Delhi as how much? 250 upon 50 as 5 hours, right? But now if I increase my speed to, let's say, 100, I would be getting 2.5 hours, right? Which means that if I increase my speed, right, my time decreased, which means that these are inversely proportional to each other. Clear? So, from this concept, we will be doing our very first question. The questions will be appearing on your screen. So, our first question is that we are given the ratio of speeds of three people, namely P, Q and R. They are given in the ratio of 1, ratio 2, ratio 3. We are given the speeds. Okay, you have to find the ratios of their time taken. Just think for a minute. Just now I told you a relation between them, right? So using that relation, I will get simply the reciprocal of it, right? 1 upon 1 ratio 1 by 2 ratio 1 by 3. But this is not our final answer, because in fractions we have to compare our fractions with one common term. So what we will do, we will take out their lowest common multiple and it will come out to be the product of the consecutive numbers 6. 1 into 6, 6 into 1. Similarly, 2 3s are 3 into 1, 3. 3 2s are 6, 2 into 1, 2. Right? So, this is my final ratio of their times taken, 6 ratio 3 ratio 2. Right? I hope it is clear to all of you. Now remember one thing. If you were given only the ratio of speed of P and Q, that is 1 ratio 2, you could have wrote your answer simply as the ratio of the times will be 2 ratio 1. Because only think for a moment that 1 upon 1 and 1 upon 2, if you cross multiply them, you can simply get your answer. Right? So this method is only applicable of lowest common multiple if you have a question in this form where you are given 3 or more than 3 people. Right? I hope it is clear to all of you. Now moving on with our next type of question. Now we'll be doing our hardcore applications of speed, distance, time, but still I would say that these are the very basic building blocks of this chapter, right? So moving on to question number 2, we are given John, if he walks at 4 by 5th of his usual speed, he takes 25 minutes more to reach a place, right? You have to find the initial time taken or the usual time taken initially. Right? Now, if you would have noticed it here, the speed of this person has clearly decreased, right? It has become 4 by 5th or 0.8 of his initial or usual speed. A decrease in the speed has given us an increase in the time, right? So the distance in both these cases will be same because he is only going from that same place to another place, right? So using the formula of distance, we will get let speed is equal to s and time is equal to t. But now the speed has become 4 by 5th of his usual speed, and with this our time has increased to 25 minutes. Clear? Now you can easily cancel out this s and you will be left with t is equal to 4 into t plus 25. You will take this 5 to the other place, you will get 5t, right? Now solving it, you will get 5t is equal to 4t plus 100. We will group the like terms and we will get t is equal to 100 minutes, right? Or we know 100 minutes is equivalent to 1 hour and 40 minutes, right? So this is our final answer. I hope again it is clear to all of you. Right, a very simple and basic understanding. I hope you can all relate with the question very well. Right, anyways, moving forward. Now, this is what I would say the classic question of speed, distance and time, and it comes in many question papers and Olympiads and competitive exams, right? Now, listen to the question carefully. let us say a person called Karan, right? He walks at a speed of 20 kilometers per hour, right? And reaches a place 10 minutes late, right? And if he walks with a speed of, let us say, 30 kilometers per hour, he reaches the same place 10 minutes early, right? You have to find the distance between both the places. I hope the question is very clear to you, or you can pause the video to again see the question. Now if you see, we are not given any reference point of the time that he had to reach, or the correct time hasn't been given to us, right? So we will frame the question according to our need. Now let us say he is going to office, right? So to reach the office, the normal time is how much? 9 a.m., right? The correct time. However, if he walks at a speed of 20 kilometers per hour, he will reach that place at 9:10. Clear? Inverse relation. And if he walks at a speed of 30 kilometers per hour, he will reach the same place at 8:50 am, right? Can you see one thing? The relation between these two, or the difference between these two times, is how much? It is exactly 20 minutes, right? So now we will frame our question in terms of time. Time is how much? Distance upon speed. So let distance is equal to x. So x upon 20 minus x upon 30 will give me how much? 20 minutes. To change these minutes, we will divide it by 60. So we will get, 1/3 of an hour. So I'll simply convert it into 1/3. I hope you have got the main idea behind it. Now I would take the LCM, lowest common multiple would come out to be 60. I will get 3x minus 2x is equal to 1/3. 3 ones are 3 into 20, and here I would get x is equal to how much? 20. 20 what? 20 kilometers, right? So this is our final answer. I hope it is clear to all of you. Moving on. So moving ahead, we have our next question with us. Question number 4. Right. We are given that a man covers the first half of his journey at 21 kilometers per hour. Right. He covers the second half of the journey at 24 kilometers per hour. And the total time taken by him in doing all this is 10 hours, right? And you have to find the distance, complete distance for which he traveled, right? Now we will make a clear visualization of this question, right? The starting point, the ending point. I'll divide it into exactly 2 halves, and I'll take my whole distance to be 2x, right? 2x is only to make our calculations more simply, right? More simple. So the first half will be x, so will be the second half, right? Now I am writing down an equation in the form of what? Time, because that is how the question has been given to us, in the form of time, right? So time is equal to what? Distance upon speed time is equal to what? Distance upon speed, right? So this time plus this time will give me equal to 10 hours, right? Now you can find out their lowest common multiple. If you follow the right method, you would get it as 168. 21 8s are, 24 7s are, right? And you would get it as 15x is equal to 1680, or x is equal to how much? Sorry, 1 1 2, right? 112. Now you have got this as only your first half of the distance, so you would have to multiply it by 2 and you would get as 224 kilometers was the whole distance, right? Don't do the mistake of only giving 112 as your answer. I hope it is clear to all of you. Moving on further, our next question is a little bit different and perhaps a little bit challenging. In our fifth question, we are given that a person takes a total time of 6 hours and 30 minutes while walking and riding back to a certain place. However, he gains 2 hours and 10 minutes if he rides both ways, right? You have to find the time taken by him if he started to walk both ways, right? Now what I will do here is I will only show you the way and you will leave your answer in the comment, right? And the answer which will be right, I will give it a like. So just understand the concept. He is gaining time if he is riding both ways, which is obvious. He will gain how much? 2 hours and 10 minutes. So it means that it will take him 4 hours and 20 minutes, right? Now we can frame our equation as time taken by walking and time taken by riding back. Time taken by riding both ways, right? 30 minutes mean half an hour or 6 1 by 2. 20 minutes means 1 by third of an hour or 4 1 by 3. It gives us how much? 2 6 are 12 plus 1, 13 by 2. It gives us how much? 13 by 3, right? Now what you can do, you can use this 2TR, right? I think the marker is working pretty light, so I will rewrite it, right? We will take only this equation, 2TR is equal to 13 by 3, or TR is equal to 13 by 6, right? We will put this TR in our first equation. So we will get TW plus 13 by 6 is equal to 13 by 2. And time taken by walking would be equal to 13 by 2 minus 13 upon 6. And it would give us what? 6, 2, 3s are 3 into 13, 39, 6 1s are and 13. So it would give me 26 upon 6, or cutting it by how much? 2, I would get it 13 by 3, right? But mind it, this is time taken only for one side of walking. You have to calculate the total time taken by him walking and returning to the same place. So you would what? Multiply it by 2, and you would leave your answer in the comments in the units of hours taken by him, right? And I'll be doing further 2 videos of the concept of relative speed and upstream and downstream. I hope you all stay tuned to it. Please like and subscribe. Thank you.